We are working through exercise 10b, and in this video I'm answering question 13, which says, if no digit can be used more than once, find how many numbers that can be formed from the digits 3, 4, 5, 6, and 7 are. And for A, we're trying to find 3-digit numbers. Now, I want us to use our permutation notation for this question, in which we're trying to find our n and r value. My n value is the amount of objects I have. So in this case, I have 1, 2, 3, 4, 5 digits I'm dealing with. So I have 5 digits to choose from. And now I need to figure out my r value, which is in terms of the size of the group, or in other words, the amount of places I'm trying to fill. So if it's a 3-digit number, I obviously have 3 places I'm trying to fill. So now that I have it in this notation, I really hope that you're able to utilize your CAS calculator to answer this question. So you're going to go to menu, you're going to go to probability, then you're going to go permutations, then type in your n value of 5, then your r value of 3, hit enter. Your answer is going to be 60. But let's see now why that is the case. And it's because this is telling us that we have 5 factorial over, now our denominator is n minus r factorial, so it's 5 minus 3, and then we're taking the factorial of that. So 5 factorial over 5 minus 3, that is 2 factorial. Now I can write this out as 5 times 4 times 3 times 2 times 1 over 2 times 1, in which this and this are going to cancel. So I'm just going to be left with 5 times 4 times 3, 5 times 4 times 3. 5 times 4 is 20, times 3 is 60. 60 is going to be my answer. But notice how quickly we did that just by using our CAS calculator. Perfect. Let's now move on to B. B is saying, I am now trying to make a 3-digit number, but I want it to be even. So what are the arrangements that I can create 3-digit numbers that are also even? So to do this 3 here is what we call a restriction, and we have to deal with that first. So I'm actually going to write out my 3 places, and we're going to think of the amount of possibilities I have for each one. So let me come here, grab that. Now, if it is an even number, let's really think about what that means. If I give you some examples of some even numbers, they're like 12 and 18 and 1000, there could be, you think of even numbers, all it has to be even is end in an even number. It could be any number in the world. It just needs to end in an even number. And if it ends in an even number, then the number itself is even. So that's really the trick to these questions. When it says an even number, all it means is the number ends in an even number. Let me all rub that out. I'm sure that's obvious to some of us, but for some others, it might just take us a bit of reminding, like, yeah, if it's an even number, it just ends in an even number. It's not any more complicated than that. So now we have to ask ourselves, well, how many numbers could I put into my last spot that are even? Well, I come up here and I see that I have 4 and I have 6. So I have 2 options for this spot right here. So I'm going to put 2 in there. Now, let's start at the beginning again. Now, I'm not going to have 5 possibilities for this place, even though that I have 1, 2, 3, 4, 5. It's not going to be 5 here because I've already used one to satisfy my restriction, which means it's going to be 4. Because I've already used one, and then this one therefore will be 3. And now I just need to solve what this is. 4 times 3 is 12, times 2 is 24. So my answer will be 24. Let's now move on to our last question, which is C, which is asking me to find an arrangement which is greater than 700. And let me just rewrite the numbers that I'm dealing with, 3, 4, 5, 6, and 7, just to remind me. Okay, so I need to think of numbers that are greater than 700, and I have these numbers to deal with. Well, for a number to be greater than 700, I know that if I use all 5 digits, even if my number starts with 3, it's still going to be bigger than 700 if I use all 5 digits. Now, I could write that with my permutation notation. I have 1, 2, 3, 4, 5. And I'm trying to make a 5-digit number, so I have 5 groups. And we can solve what that is a bit later using our CAS. Now, if it has to be greater than 700, it could also be any 4-digit number. So if the number has 4 digits, it will also always be bigger than 700, even if it starts with my smallest number of 3. So again, I have 5 options, and this time I'm making a 4-digit number. So it's going to have a 4 as my R value. Now, so let me just highlight this as we go. We've got 5-digit numbers, we've got 4-digit numbers. This is where it becomes tricky now, my 3-digit numbers. Now, I am going to have some 3-digit numbers which are greater than 700, but there are going to be restrictions for this, just as we saw in the last question. So let me put out this. So we're going to do this like how we did part B. So let me come up a bit more, or let me do some rearranging just so I can see this. Let me do that, bring everything up, and bring this up as well. Okay. Now, in order for this to be a 3-digit number, which is greater than 700, that means that my first number is going to have to be 7. Because if my first number was 6, and then 7, then 5, that isn't bigger than 700. If it began with 5, then no matter what I put after it, it's not going to be bigger than 700. The only way I'm going to get a 3-digit number, which is greater than 700, is if it begins with 7. It could be 7, then my smallest number, 3, then 4. That's going to be bigger than 700. So the restriction is that the very first number has to be this 7. The very first number has to be this 7 right here. So how many options do I therefore have for my first position? Well, I only have 1. It has to be that 7. Then I come to my second position. My second number can be anything that it wants, but I've already used up 1, so that means it's not going to be 5, it's going to be 4, because I've already used a number to get that 1, and then the last one I've used 2 numbers, so it's going to be 3. So now it's going to be 1 times 4 is 4 times 3 is 12. Now I'm not done yet. Let me just clean this up a bit more. So I have 12. Let me highlight that in green. I now need to figure out what my 4-digit numbers will be. So I need to bring up my CAS. And I'm going to go menu. I'm going to go probability. I'm going to go permutations. I'm going to go 5, 4. Enter. It will be 120. So I'm going to come over here and write 120. Then I'm going to highlight that. Then I'm going to go back to my CAS. There it is. And now I need to put this one in, 5P5. So I'm going to go menu, probability, permutations, 5, 5, enter, 120. Now, don't get thrown by the fact that they're both 120. The reason is because I have 5 numbers to choose from, but in this case, I have 4 digits, so I have a bit more flexibility. I could give this a big, long explanation as to why that occurs, but it's something that you could really figure out by yourself if you just kind of sit down and write down some possibilities for yourself. So I want this video to be as concise as possible. So I might just leave that for your own exploration. That is also going to be 120. Okay, so we're trying to figure out how many arrangements of numbers can be greater than 700. So we figured out that there are 120 arrangements which will be greater than 700 for 5 digits. There will be 120 arrangements that will be greater than 700 for 4 digits. And there will be 12 arrangements of 3-digit numbers that are going to be greater than 700. Now, obviously, if it is a 2-digit number or a 1-digit number, it's not going to be greater than 700. So what I have to do now to answer this is simply add all these together. So it's going to be 120 plus 120 plus 12 to get my final answer. So that is going to be 240 plus 12 will be 252, should be my final answer. And it is 252, 2460. Perfect. Hopefully this video was helpful to you and you now understand it. This was one of the maybe more trickier ones in the exercise. So if you do need some more clarification on it, please reach out and we'll try to help you.